Hello friends, welcome to Maths Hub. Now we discuss about undirected and directed graph, simple and multigraph, isomorphic graph, path, simple path and simple cycle. Now first we discuss about directed and undirected graph. First for directed graph और digraph. Directed graph का ही second नाम है digraph. A graph is a directed graph when the pair of vertices representing any edge by an ordered or a direct pair v1, v2, where v1 is the tail and v2 is the head of the edge. Now we see v1 to v2. Thus, v1, v2 and v2, v1 represent the two different edges. For example, this is the digraph or directed graph. VG A, B, C, D and E. Now EG A to D, D to D and B to A, E to D, B to C, D to D and E to A. Now define to undirected graph. A graph is called undirected graph where the pair of vertices representing any edge is unordered. Thus v1, v2 and v2, v1 represent the same edge. For example, A, B, C, D, E is the undirected graph where VG is equals to A, B, C, D and E and EG is equals to A to B, A to E, A to D, B to D, B to C, C to D and E to D. Now second, simple and multigraph. Simple graph. A graph that has neither self loop nor parallel edges is called a simple graph. For example, V1, V2, V3 and V4 are 4 vertices and E1, E2, E3 and E4 are 4 edges. Now next, multigraph. A graph may have multiple occurrences of the same edge. When this restriction is removed from a graph, the resulting data object is referred to as multigraph. Now, for example, V1, V2, V3 and V4 are 4 vertices and E1, E2, E3, E4, E5 and E6 are 6 edges. Now third, isomorphic graph. Two graphs are called isomorphic if their theoretic properties are same, or two graphs are called isomorphic if there is 1-to-1 correspondence between their vertices and between their edges such that their incidence relationship preserved. Two graphs are called isomorphic to each other. First, they have same number of edges. They have same number of vertices. Third, they have equal number of vertices with given degree. Now, for example, the two graphs are isomorphic is since two graphs have same number of vertices and same number of edges. Now, third, degree of A is equals to degree of A dash is equals to 1. Degree of B is equals to degree of B dash is equal to 3. Degree of C is equal to degree of C dash is equals to 2. Degree of D is equals to degree of D dash is equal to 2. Degree of E is equals to degree of E dash is equals to 2. These two diagrams for isomorphic graphs. In this, A, B, C, D and E vertices and E1, E2, E3, E4 and E5 edges. Similarly, A dash, B dash, C dash, D dash in E dash are vertices and E1 dash, E2 dash, E3 dash, E4 dash in E5 dash is edges. Now we see degree of A is equals to degree of A dash is equals to 1. This E1 and E1 dash. Now degree of B and degree of B dash is equals to 3 because E1, E2 and E5, these 3, and B is equals to E1, E2 and E3 is equals to these 3. Similarly for degree C, D and E. Therefore, two graphs are isomorphic. Fourth, path, simple path and simple cycle. For path, any sequence of edges of a digraph such that the terminal node of the edge in the sequence is the initial node of the edge, if any, appearing next in the sequence defines a path of the graph. A path is said to traverse through the nodes appearing in the sequence originating in the initial node of the first edge and ending is the terminal node of the last edge in the sequence. Now, an open walk in which no vertex is appear more than one is called a path. Examples: A, B, C, D, E and F, in which we find two paths. Path is equals to 2. Now, definition of simple path. A path is a digraph in which the edges are all disjoint is called a simple path. Example: A, B, C, D and E, and these edges are E1, E2, E3, E4, E5 and E6, and last is E7. Simple path are first A to B to C and C to A. Now second condition is A to B to C to D and then A. Now definition of simple cycle or elementary cycle. A path which originates and ends in the same node is called a cycle or circuit. A cycle is called a simple if its path is simple, that is, no edge in the cycle appears more than once in the path. A cycle is called elementary if it does not traverse through any node more than once. Now note that a cycle, the initial node appears at least twice even if it is an elementary cycle. Example for this cycle. Okay, 1, 2, 3 and 4. Now starting from 1 to 3, then 4 and 1 is a self loop. And then the following sum of the cycles in the graph of figure C1 from 1 to 1, C2 1 to 1. Now C2 1 to 2 and 2 to 1 to 2 and 2 to 1. Now C3 1 to 2, 2 to 3 and 3 to 1. Now C4 1 to 4, 1 to 4, 4 to 3 and 3 to 1. Now C5 1 to 4, 4 to 3, 3 to 2 and 2 to 1. Thank you for watching this video.